Okay. Last lecture, we started working on top of data, which was survey or case study. I told you that survey data set is different with kind of data that we collect from lab and we measure, we put it there. This kind of data is more like information like yes and no, good and bad, how well you are doing in the class, and that kind of survey that they do, okay? And the numbers that we have, so we had this Excel file, and I said the number that we have like months of absences. So the 7 is not a number or a value that we measured. It's just a sign. 7 or 1 represent January, okay? It's not something that we be able to do calculation on them. So these kind of things important about our data. We need to understand what type of data we have, what they mean, what each number in the column and row means. And according to that, we can go ahead and do some data analysis. So we have this survey. This survey is a case study. They collect this survey from absentees at work. They ask how far they live. They ask reason of absentees, which months they were absent, which week, which day of the week, and what is the transportation expenses that they pay, distance from work, and that kind of thing. Their age, if they are social smoker or not, and that kind of things, okay? Let's go back to our code. So Luis, you can just do this few codes, okay? Just import pandas, import matplotlib, and read the file exactly right like this in your Python code, and this info function, and do till here, okay? Till here we are okay. Just do that. Okay. Last week, we import our library that we need and we wanted to use, like pandas and matplotlib. After that, we read our file, our Excel file, and we import it exactly like this. Then we use this info function to get quickly a general information out of our data set. So our data set has 740 entries, 740 rows, and 21 columns. Here we have the name of columns and data, the rest of that. And I think we did box plot, a scatter plot, and we saved also our graph and that kind of things. Okay, at the end of last lecture, I said, I want to use each column, okay? Like reason of absence is, in this type of data, we all the time keep going with columns, columns, columns. Therefore, I'm gonna use these columns a lot. Here, I wanted to come and create a short variable equal to each column. So instead putting all this line of codes into my functions, quickly I just put A inside that one, okay? And I think this A, B, I'm gonna get confused also with this A, B, C, D that I put. If we go further, like here also we receive the error. I'm gonna put a kind of name that at least I understand, okay, if I put like age, reason, months, I'm gonna put like this. So here I'm gonna put just reason. Okay, you put something that you understand what is that. So I thought if I put ABC, I get confused and I don't know what is F mean, okay? If you are okay with that, just go with that one. I want to say, I want to write reason, month, day, and that kind of thing. Now my Jupyter notebook stopped working. Reason. So for this one, I'm gonna put reason. Here, I'm gonna put just months. And here, day. This way I at least understand quickly that what this season, this day or season mean, okay? Transport, and this one gonna be distance. Service time, I may not use this service time. No, I will not use this one. I'm gonna just comment out, or we can delete it. So I'm gonna pick up some columns that we're gonna work on them, and I just show you as an example that what we try to understand from these columns, okay? Not all of them. So you may do more, and you can do even more things on this data type. So I'm gonna just quickly go and show some example. So service time, I'm gonna delete this totally. We don't need it. Age, okay. Age and workload average day. I don't know, workload average day. I'm gonna delete this part also. Education. We can have some example on education. Sun, okay. Social drinker, if they are drinker, if they are a smoker. Body mass index, actually this show their weight, okay. And absence time in hours. Okay, I'm gonna say here hour. Like last time I also said that I'm not sure how the person who did this survey put like consider this column. Absence time in work, probably that means how many hours they were absent. I just consider it as that one, okay? So first thing that we learned that describe function, okay? We can use describe function. Describe function quickly can come up and give some information about column, like minimum, maximum, and percent, 75%, or mean, average, and that kind of things, okay? This describe exactly work like this box plot. Do you remember that box plot? Box plot is the visualized graph of describe. They work like each other almost. And the other function that here for this kind of data set we can use it is histogram. See what kind of data visualization or data analysis I'm using on this type of data. I cannot use that much measurement or measurement kind of data analysis, data analyzing on this type of data because this is survey. This is not some kind of data that we measured. Next week, we're gonna have lab measurement data set. Then we're gonna do regression analysis and that kind of measurement. Okay. Here for transportation, we did some describe function. Then we did box plot. And we saved, we did a scatter for comparing E and X. I think it was this transportation and absence time in hour. We try to understand if this transportation expenses can affect the time that they are absent at work. Let's run this one. I'm running, okay? Okay, here from this info function, I have this data, okay, quickly. And this is describe function, okay, the data from describe function. I'm gonna just comment out. I don't want to keep printing this part. I'm gonna comment out and then run it, okay, here. Now let's see what we can do. I'm gonna go and do describe on kind of columns that more like I can do this one on distance because distance is a kind of measured data and I'm not sure if they set it as a kilometer, like per kilometer. So we can do describe on this distance. And also we can come and check if distance can affect the absentee time in hours, okay? If people who are far from work, they get more absent in at work or not. So let's do that one. I'm gonna do describe, okay? I'm gonna do describe on distance from residence. We did with this transportation expenses, okay? I would not do this one. Here, we're gonna do that and then also do box plot on that one. For comparison in the big like data, the best thing that we can do for comparison is a scatter plot. Let's go and do this one. I'm gonna say distance from work is distance, okay? Dot describe. You remember how we were using this describe function? We put the file or where the file or column or where we want to use describe on top of it, and then writing this describe function. Okay, I have this describe function. We are now using Jupyter Notebook, but the correct way to using this code is using print or show function. Okay. In other, as I said before, in other compiler, we all the time using this print and show because it would not show or print anything out rather than you tell your program to do that, okay? We're gonna say print, describe of distance, and then let's go and do box plot also. From matplotlib, I'm gonna use box plot. Box plot is so similar to the values that describe function show it to us, okay? Box plot for what? First, I said for box plot, we just has one data set, is the data that we want to create box plot on top of it, which is distance, okay? Distance. I'm passing this distance, this line, okay? Here. And we want to also show means in our box plot. Show means equal true. Anytime we create our box, remember, next thing is making title and label for that graph. And after that, if you want to like change size, color, and that kind of things, you can do it. plt.title, okay. I'm putting a title for box plot. I can tell distance from residence. Distance from residence. Okay. And here I'm gonna show plt.show function, okay? That show function in Jupyter Notebook, if we don't even write this one or print, it is still printed out. But the correct way is that using print and show function, okay? And I think that's it. Let's run. Okay, here we have count how many data we have in distance column and the mean average. Here you see, so here we have mean, okay, almost 29 to 30, and here this green dot is our mean on box plot, which is exactly correct to 30, okay. The minimum, the smallest value that we have is 5. Someone paying 5 distance from residence to work, 5 kilometers probably. So the person who, someone lives like 5 kilometers far from work or something, and the maximum is 52 if it is 2 kilometers, as someone living 52 kilometers far from work. And this is the percentage and that kind of things. Okay. The other things that we can use in this type of data is histogram. Okay, like how many people live in this distance, in the other distance. Okay, I'm gonna also print out that histogram for this distance. Okay, and after that we're gonna go and analyze, see if this distance can affect the absenteeism hours at work or not. Let's do histogram. For histogram, we're passing this distance data. And beans, if you remember, we were using beans, so I'm 20, let's put 20. No, let's make it bigger, like 50. I'm not sure yet. And now I'm gonna say plt.show. Okay, after each graph that I create, I put a show function next to it. Okay, let's run it. Most of people, like here we see, this is a histogram, was showing frequency, okay? The number of that values that we have in data set. It shows most of people have like paying like 26 something. And then also this part, we have many people that not paying, I'm sorry if I keep confusing between this distance and transportation fee. So this is how far from they live. Mostly is 25 to 26 kilometers far from work. And also here we have many people that they live far from work, like 50 kilometers. If it is 2 kilometers, too much, something like that, okay? This is the way that we use this histogram. And after that, you learn how to label, like changing the size and other things, okay? And after that, for this distance, let's compare this distance with this absence time in hours. Let's see if when distance increase and get more can affect the absence time in hours or not, okay? I'm gonna use this scatter plot from matplotlib.pyplot. I'm using this scatter plot. And for a scatter plot, I'm passing two x and y values. So we can put distance. Let's put distance. I'm putting distance as a x axis, and what was the last one? Hour. Hour means absentee's time. Okay, hour for the x axis. And let's see how this is gonna work, and will show data to us and see if there is a relationship or not. Okay. Okay. This is our scatter plot. Okay. So I do not put title and that kind of things because I think you learned, but you can put it. Okay. Also X label, Y label, grid, legend, and not legend actually for a scatter plot or a histogram. It doesn't work for them, but you can design a change color and that kind of things. Let's look at this scatter plot that we got. So X-axis is distance that continuously increase, okay? In a scatter plot, when we put something on x-axis, it continuously come and just decrease the values, okay? And for y-axis, we have this R, okay, that we consider, okay, maybe they ask how many hours they were absent during work, okay? We try to understand, is there any relationship between this distance and hour that they are absent or not? As I look at here, so even people who are close, look at this. People are close, still we can see that they have many hours absent. And they were absent for like many hours. See, while they are leaving, this is a distance, okay? Like 10 to 15 kilometers away, but still they have, they're absent like for a long time. But here is the people who were living far away, okay? Like 50 kilometers far from work. By the time that they were absent is less. So I was thinking maybe that distance can affect, but we see no, there is no special relationship between distance and being absent. That was on the column of distance, so we can understand and figure out this kind of information from our data. The other things that we can understand and check is, let's go for, I think we didn't do reason for absence. Okay, here I want to understand what is the most reason that people get absent, okay? Or in which month they are more absent, or which day or season they are more absent. This is kind of data that in through histogram, which show frequency, we quickly can figure it out, okay? Let's go and use histogram on this for a column, reason, month, day, and season, okay? Here on this one, when you want to save it, exactly use this line, save figure, okay? Save figure function, and wherever with what any kind of name that you want, just save it, okay? Here, let's create some histogram. Okay, I'm gonna create that histogram for, I said, reason dot hist. We had month, day, season, month, day, season. PLT dot hist, PLT dot hist. First one, I'm gonna put this reason and beans. Also, if you don't type this beans, it should be okay. It won't give any error, okay? Reason, months, day, and then season, okay? If now I run this one, it's gonna bring reason. If I print it out, they're gonna put all these histogram graphs inside one graph. So let's run it and see. See how it just put it all together inside one graph, okay? When we want to separate it, either you can put each one of this in different place, okay? Or putting this show function after each graph that you create. Put show function after each line, or either put them in different space And also we can use that subplot, okay? Let's just use that subplot. Do you remember subplot? From plt dot subplot. Subplot was something that I was telling, okay, my whole graph gonna have like 2 column, 2 row or something. Now here we have 2 column, 2 row, okay? In 2 different ways we can put subplot. The one that before I told you. So for this line, okay, we put the place of this line. We say this is 2 column, 2 row, and this one is in the first like column, something like that. Or either I can say this, okay, my subplot or the whole graph has 2 column, 2 row. I'm gonna make the index number of my graph and put this histogram in that index number. Anytime that we want to use index of this subplot function, there is 2 keywords that we put first, fig, comma, axis. Fig, comma, axis is something that all the time need to be there, okay? This keyword. And here I come and say x index number in row and columns, okay? Like this. Axis.histogram. In which index number and index position I want to put this one. So I want to put it in 0, 0, the first place, okay? 0, 0, something like that. And here let's do same thing. Axis. Subplot comes and many graph that you have put it inside one and printed as one whole graph, okay? Not inside one shape, it put it next to each other, okay? This one can be 0, 1, index position, row 0, column 1, okay? Here I'm gonna do same thing, axis. This is gonna be row 1, column 0. Row 1, column 0. Now let's print it out. Fig axis. This axis of fig 1. Oh. Okay, I did a mistake here. In subplot, it's subplot S. There is a S at the end, okay? There is an S at the end, so this one. Here we had that problem. Let's run it again. Okay, so it printed out our histograms nicely in our subplot, which has 2 rows and 2 columns. But here, because I put the same like index number for both of them, it just put both of this histogram into each other, okay? So I'm gonna change it and put 1 here, and now let's run it. Now see, we have this histogram. And then you want to just save it. We use this one. I commented out, but you can do save it this one, okay? plt dot save figure, and save figure as what? Like histogram dot png, okay? Histogram dot png. And the pixel or quality DPI gonna be 100, exactly like this one. Okay, it's gonna save all this histogram that you have. If you want to make it a special and just different, this subplot most of the time used for something that they have like at least equal axis or equal y-axis, x-axis or y-axis, and they are similar to each other. Okay, subplot mostly used for that kind of type of data, which this axis is all same here. Okay, here is same, here is same, but here is a big difference. I just show it as an example in this kind of type of data, because you see, so this is up to 150 and this is 200, and here we have just 4, but here we have like up to 30. So this make it like size up your graphs a little unequal. We can make them like separately, just print them separately by putting that plt.show function, or just print it here or something like that. Okay, so this was also an example of subplots for that kind of data. For this reason, I want to print out histogram of reason separately here. Okay, let's make plt.show. So here I was trying to understand what is the most common reason that people are absent at works. 23 is actually the most common reason that people are absent. Okay, if we go to this one, oh no, not this one, to that PDF file, there was a PDF file which was explaining about all attributes. So 23rd or 20. Okay, 22, 23rd, 24 is like medical consultation, blood donation. Oh, 22 is patient follow-up. Medical consultation was a kind of the most common reason that people are absent. Okay, patient follow-up, medical consultation, and this kind of things. Also, there was the last one. What is the last one? The last one is also common. See here. Do you see the last one is common? What is the last reason? Dental consultation. Dental consultation also was a reason to being absent. Okay. This is something that we understand from this reason. And here we had month. Each month people are mostly like, this can be so. If I change size in subplot, it may not change the size. Let me change size because this is so small. Okay. The problem of subplot is this. It doesn't show your data accurately. If you want to just make it accurate, just print it separately. Here I try to change the size, plt.figure. Plt.figure is a function that gives a lot of ability to you to do setting on your graph, okay? Like color, size, and that kind of things. So a figure function has an attribute or argument, has an argument, call it fixed size, which you can pass the size of your graph into it. So if I want to be 10 to 10, let's see how it can change. Let me put 20 to 20. Okay, it changed actually figure size. If you notice here, this number keeps changing, which is the figure size. But here we cannot see it, okay? but it shows that it keeps changing the size. Let us check this figure function, what else this figure function has, okay, that give us changes on our graph. Plot flip dot plot dot figure function, okay. Okay. It has num, we can pass num, int or a string. Num can be int or a string, and it is optional, a unique identifier for the figure. Okay. If a figure with that identifier already exists, that's figure, okay, that's just number of figure. Okay, it can print out number of figure, figure size, pixel and quality of your figure, face color. It can change the face color, edge color, okay. Frame on true. What is this frame on? Boolean type of data by default is true. Suppress drawing the figure frame. Okay, so frame on, figure frame. Okay, I got it. Put a frame. Figure class, lesson class, methodology dot figure. Okay, clear equal false, and that's it. Okay, so this was our figure function and all things that we can do on our graph. So like put a number for your graph, figure size, quality of your figure, pixel, face color, edge color, frame, and figure class. Okay. Let's go back. For months of the histogram of months, it showed that in month 6, we have months of absences, which is like May, June, and also the last month, month 12, okay? Month 12 is the most of absences, which December. So during December and June, we have most of absences, or most of absences happen. After that, we have day here. So 2 was Monday, 3 was Tuesday. I don't know if we can consider that there is more absences in some days or not. And for season, actually season is according to these months. You see, we said that in like June, which is season 2, April, we have more absences, and also in December. See here, which is like last season, winter, no, fall, sorry, fall, we have more absences, okay? Do we need to compare? Okay, now let's go season. Do we need to compare them? No. So let's go and do same thing. We can do a kind of histogram on age. Actually, on age, we can do absolutely this box plot and describe, okay? Describe, show that what is the most like absences age. If they are more young, they are more like old. And also we can do compare this age with this reason for absences. Okay, I want to, for example, know if a specific, if people get like older, or when absences are older, their reason for absences is different with young people, or it's more for disease or not, and that kind of things. However, this absentees reason was mostly for disease, but we can compare these two, see if age can affect and have some relation with this reason of absences. So let's create a scatter plot for age and reason, okay? Here I'm gonna create a scatter plot, plt dot scatter. I'm gonna put age as x-axis and reason as y-axis, okay? plt.x label, okay? I'm putting this x label and write age, and plt.y label as reason. Now writing that show function. Okay, let's look at this plt, no, a scatter plot that we have. Okay, actually, the way that dots contribute in whole graph that we have is show firstly we don't have any relationship. So otherwise, it's supposed to be when there is like people getting older, the dot's supposed to like be in a specific place around some kind of disease, but it's not. See, here you see that we have in this kind of age we have all dots and any kind of disease or reason to being absent. And even in younger parts, we have any kind of reason. So it doesn't matter at all. There is no relationship. And also we need to consider this one, that probably people who were surveyed, who were like interviewed for this survey was young or employee age, most of the time, like it is young, between 30 to 40, most of employees are. So here we understand that there is no relationship. And let's go and quickly do for this social drinker, smoker, and body mass. I want to understand if this body mass, for example, if someone is heavy or fat, it can cause to be more absent in works or not, okay? I'm gonna do quickly that histogram for these two, social and smoker, drinker, and body mass, okay? Drinker, smoker. PLT is for a smoker, okay? It's gonna be a smoker, and I'm gonna say PLT dot title, social smoker, okay? And then here I'm gonna say show my histogram. Then I'm gonna go and do same graph for drinker, if they are social drinker or not. And plt dot title, I'm gonna say that this graph is for social drinkers, okay? Drink. Now plt dot show. Let's run it. Okay. For social drinker and social smoker, we have only yes and no. No is 0, yes is 1. Here, either we can do not show it like this. Either we can use that bins, okay? Do you remember this bins? Change it, or that X ticks or Y ticks. Okay, let's first use this bins. I want to my bins be only 3. like 0, 1, 2. And here also my beans be 3 or 4 or something. Text object has no property beans. Where I made a mistake. Beans. Oh, I'm sorry, I put it on title. I put it in title function instead histogram function. Okay. We put beans in our histogram function, not in title. Okay. Now let's run it. Now let's run this one. Okay, social smoker. So most of absentees are not a smoker. 0 mean no, 1 mean yes. Yeah, am I correct? Let me check this PDF. 1 mean yes, no mean 0. Okay, 1. Yes mean 1, no mean 0. Okay, I got it. 0 mean no. So most of them are not social smoker, but they are social drinker. For social drinker and social smoker, we can create quickly that box plot. Box plot can explain it well. Let's create. Let's create a box plot for this one too. Okay. plt dot box plot for a smoker. And what else? Show means equal true. We want to display means also, and then plt dot show. Let's put same thing for drinker also. I copy paste it, and here I can just say drinker. Okay. And describe also can help here a lot. Let's run it. Social smoker. Yes or no? Actually, no. Box plot does not work for this one. 0 to 1 and yes, box plot does not work for this one. We shouldn't use box plot because the whole range of data that we have is 0 and 1. It can just show your number is between 0 and 1 and that's it. So 60%. Here average is 60. We may use describe is better, or probably this histogram actually was better, showing better data. And 60% are drinker, but not a smoker. It looks only 1% was a smoker. A few people were a smoker. See? So box plot is not a good option for these two sets of data. Now let me compare them if this social drinker or social smoker can affect to be more absent during work or not. So instead this one, I'm gonna use a scatter plot, okay? I said to comparing this type of data, a scatter plot is a good thing. Okay, here I'm using a scatter plot. For a scatter plot, I'm passing a smoker and R. Two type of data that we had for X and Y axis. Okay, I'm gonna do same thing here for drinker, passing drinker, and for Y axis, I'm passing R. Inside box plot, I'm gonna put a scatter. See if it can have some relationship or not. Okay. Okay, y-axis is R, and it's no. Social drinker. Okay, here they are not. Okay, in social drinker we can see that. Okay, some of our like employee are not social drinker, but still like long time that they were absent for many hours. So here also same thing. There is not that much relationship. So because if there was a relationship, we must see, okay, if like they are drinker, there is more dot and most of the dot here in this corner up, not down, and here down. But no, there is not such kind of relationship. So here, social drinker who is not social drinker, still they have a lot of time that they are absent. And some few employees, they were just social, actually so little of our employee were social drinker. You see, less than like 70 people were social drinker, and this is also the time that they were absent, which there is no like relation. And we have the last one we had, which is this body mass index, which is weight. So we can see if the weight also has that. Let's check if the weight has any relationship with these hours or not. Okay, I'm creating one scatter plot, our last scatter plot here. And then next week, we're gonna do like clustering and that kind of k-mean probably. K-mean analysis on this type of data. And after that, we're gonna change our data set going to measurements for like lab data set. A scatter, so I'm gonna put weight over R. So here is weight. I don't know, their weight is according to what? Here didn't say body mass index according to what they put it here, but okay. So here still the average of people is like absent, and it doesn't relate it if they are thin or fat. So if there was a related, I thought it may be like people who are like have like they're more heavy, maybe they may are more absent at work, but there's not such kind of things. So people with any like body mass index or any weight, they can be absent, or some of them even like absent for longer times at work. And this is a kind of like visualization and data analysis that we do on survey type of data, okay? This was a case study, a survey. For next week, we have a data set of lab, which was measurement. They measured, and we're gonna do regression analysis. The type of data that we do is a little different. I just wanted to practice that graph visualization that we learned, that how we describe our data and put real data in this kind of graphs and explain it and analyze it, okay? If you have any question, please ask me. Otherwise, I'm gonna see you all next week, Tuesday.